This next phase, we get into the world of software testing. So we've gone through the requirements phase, we've gone through the design phase. We're kind of skipping over implementation for now, jumping into testing as the next thing we'll talk about, because it's really the next unique phase that's not covered in a bunch of different ways. We're not here to talk about how you code stuff. We're just kind of applying all this stuff together, skipping into testing for now. So the question is, what is the goal of software testing? So generally speaking, testing is where we know if something's acceptable. If you're cooking, you take a little spoon and taste your dinner before you serve it up. If you buy some fancy clothes, there's probably going to be a little tag on the pocket that tells you who is the inspector. If you're going to buy a car, you take that specific vehicle you're going to buy out for a drive. Make sure you like it and that specific vehicle drives well, not just the class of vehicle, that specific ones. The difference here, though, in software is a little bit of a different story. I don't test drive individual software because it's virtual. It runs on whatever machine. So when I test it, I've got to test it for everybody all the time, not just my specific needs. So to some degree, software is easier because I don't have to test each one that comes off the factory line. But to a lot of degrees, that means when I test it, I didn't know that many unpredictable things that could go on can be tested. Like a car, you might theoretically test crashing into a wall if you're the manufacturer of a car, but you're not going to test, at least you didn't beforehand, have to worry about security issues of what happens if somebody breaks into your car and drives away with it. It's just a car at that point. These days, the hacking of a car is important because there's software in it. And in software, we have to consider what are the things somebody could do from security, from safety, from usability, from all sorts of different aspects that we wouldn't normally do. So testing is something that you do naturally when you're building software. If you've never worked on a big software project, you might not realize that testing is a huge effort above and beyond what you do just getting your app ready. If you've been taking coding classes, you do a lot of testing. You do a lot of making sure your code works. But that's typically the process more known as debugging, making sure the code works from a development standpoint. Something done by the developer is more of just making sure it's working, fixing the problems, and moving on. Formal testing that we're talking about here is a separate step. We keep working on the formal testing until we are quote unquote done. And then we finish up from there by checking out our build. We only formally deliver after we complete this formal test in a big important project. And this is an important concept that we get into process. We want certain things to be checked out formally and sometimes even independently, because often there's a separation of duties that happens where the developer builds stuff and we have a tester who tests stuff. There's a number of reasons for that. Number one is integrity. If you're the person who is building a house, it's always good enough for you because you make less money if you have to spend more time fixing stuff. If you can knock it out, get out of there, then you get more profit for that, unless you happen to be building on a contract or something like that. But typically speaking, that's the way it works. That's not necessarily to say that software developers are full of devious ideas and they don't want to do the work. It just ensures that there's somebody else giving it a check, which is the other thing, is a second set of eyes. When you build something, it works the way you thought it should build. Of course it does. You don't know what you don't know. And the second set of eyes might have a little bit more coverage of what you don't know, because you just might not have thought of something in a certain way, and somebody else might, and then, wow, I never thought of it that way. That's definitely an issue. So there's a second set of eyes that can add value to the quality of the software. And then there's financial and schedule gains, because if I have a spiral model, as we've talked about, moving on in my solution, when I finish building something, I can move on to building the next thing while somebody else goes off and tests it. And then financially, I can get the project done quicker, and often developer resources are the most expensive. Developers are the least common graduates as far as all the IT jobs. They will let testers come without getting a degree in computer science or information technology or whatever. Developers sometimes come out of business ranks or other things like that. I'm sorry, the testers sometimes comes out of that. And so typically they may be paid less. And so there's going to be some schedule gains as well. That's not to say that there's not some really well-paid testers, don't get me wrong. But if you're going to be a well-paid tester, you really have to do some great stuff inside of this, not just click through some screens. So Separations of duty does not necessarily mean formality, though. When we're talking about formal testings, we're talking about more than just saying, hey, we got this other person here that's going to do some testing for us. We want to have someone doing it, but also have multiple phases of testing and clearly document the approach that we're going to take and make sure it's repeatable in the execution. So I can't just say, yeah, Bobby and Billy and Susie are going to go off and do some testing and they'll tell us when it's good. Well, what happens if, it wasn't good and they come back? What do they test the next time? Hopefully Bobby, Billy, and Susie remember, but what if Bobby, Billy, and Susie are off to the next project and we need somebody else to come and do the testing? What did they do? What did they do to ensure quality? We want to be able to make sure it's repeatable, and that's where the formality comes in. So we're going to learn about many different types of testing, maybe different layers, if you will, of testing. These are not all required, and they're not necessarily all building on each other, and they might be doing different aspects of the system. But we'll learn about unit testing, which is your basic stuff that really is the boundary edge of the development. And I will see it's often done by development. Integration testing, and then into the real hardcore quality testing, functional testing, regressions of form of that, user acceptance testing, performance testing, and then validating the release. These are all different phases of testing. It's not to say that they're all doing dramatically different things. Sometimes they're doing the exact same things, just in different contexts, in different places, in different focuses that's going on. And so part of the game of testing is coming up with a plan of what tests need to be done, what you need to cover within those tests, and what your general approach to that testing is going to be. Now, as we said, there's a whole class on testing here at CTU, and it'll help you develop a test plan in some detail. We're not going to get into that level of detail here, but want you to be aware of this test plan highly integrates into what's happening in the requirements phase and the design phase even as well. I need to be aware of the requirements for sure, and probably the design to ensure things like performance and maybe some security features and other stuff like that are ready to go. And so that test plan is going to give us a step-by-step guide to conducting our validation. Just like the project plan tells us, the plan we wrote down for who's doing requirements and when they're going to be done, and then who's designing and who's doing the coding and all that sort of stuff. The test plan helps us know what's going to get tested, what order it's going to be tested, who's conducting it, what environments it's being conducted on, who's doing the setup, who's writing the test cases. All this sort of stuff is going to help it out. It's really kind of a shadow plan for the project. We have the whole project plan going on, and then inside of that, there's a very detailed test plan that needs to be accounted for.